Now we will consider how covalent bond is created in hydrocarbons or majorly in the organic chemistry. We divide this like a hydrocarbon division into the three groups or into the three types of element. They could be ethane, they could be methane, ethane, or they could be like alkene or alkyne. Now, when it comes to alkene or methane, sorry, yeah, it is alkene. So when it comes to alkane, it contains ethane into it. Now, what an ethane is? Ethane is basically a structure in which they create. Okay, so there are simply two carbons are attached to each other, having three hydrogen atoms side by side to them. So there are three hydrogen next to it. So they CH3 CH3 is there, and in the middle they contain one hydro. Okay, so there is one bonding present between carbon and carbon atoms. Now, definitely, they contain, so they engage three hydrogens. We have already studied that carbon can make four bonds. Now, when it engages with three hydrogen atoms right there, three hydrogen atoms right there, and the fourth one of both of them would be shared with each other. So this is called as covalent bond. Covalent bonding, uh, is present there. So simply as per your book, it is saying that ethane has a formula of C2H6. The similar bonding is to methane, but methane was a self bonding in which carbon was bonded to four hydrogen atoms. But now two carbon atoms are there, and when two carbon atoms are joined together, they are joined with each other. They give rise to two structures, which is called as they give rise to bonding between two atoms such as CH2, C2H6, and simply two carbon atoms are attached with each other by creating three extra bond with the hydrogen atoms. Now, multiple bonds could be created. More than one bonds also exist. When it comes to the diatomic bonding or the double bond is present between the diatomic molecules. So when it comes to oxygens are attached with each other. So simply an oxygen atom has six electrons in their outermost shell, and so if two oxygen atoms combine, they will both share two electrons with each. So basically, they are going to share two electrons, and it means that each atom will have eight electrons in its outermost shell, so that they could retain the mutual stability. Oxygen A will be creating double bond with the oxygen 2. This is called as double covalent bond or just a double bond. So simply that is how they are present. Both of them were containing two electrons in their outermost shell. They were demanding or they were deficient in two electrons. Now they shared two electrons with each other, and both of them attained the stability. So this is called as double covalent bond or double covalent bond stability basically. Next thing would be for nitrogen. Now, simply first thing was that monocovalent bond that we covered in the alkane or in ethane. Secondly, we just learned the double covalent bond or double bond that was covered in the oxygen. Now it comes to the triple covalent bond in which there are three bonding are shared. There are three electrons shared between two nitrogen atoms. So basically, this nitrogen atom is going to share this nitrogen atom is going to share three electrons with each other. So basically, both of them are in search of three electrons. If hydrogen came, hydrogen would have to share, hydrogen would have to act positively charged. But in this case, both need three electrons, so they share the triple bond between them. Now, nitrogen gas consist of nitrogen molecule or nitrogen molecules bonded like this. So that is how the triple electron pairs are shared between two nitrogen atoms, and that is how they would be attaining the stability like this way. Next case would be CO2. There is a double bond present between atoms. So we have studied that oxygen, that carbon, when attached to something who was more electronegative than that of the carbon, so that this time the charge on carbon would be positive 4. Why? Because he is the one who is going to share its electron in a better way. I mean, he's going to maintain distance from electron, as his electrons are going to strongly attract by both the sides of oxygen, as he is surrounded by two electronegative to highly electronegative oxygen atom. And now this carbon is going to act electropositive in nature. So this carbon would have positive charge on it. Okay, now so carbon is going to share its electron, and carbon is going to share its electron, and nitro oxygen is going to be attracted towards it. Other point would be when it comes to alkene. Alkene is simply when there are two bonds present between two atoms, or when two carbon atoms are specifically joined together by bonds or double bond between them. Now, each carbon demands four electrons. So in this case, simply there is a carbon who is going to make C. They engage two electrons in the middle, and the remaining two are created by these two hydrogen atoms. Likewise, if you move ahead, organic molecules are there. Simply when it comes to the like simply when it comes to the halogen, or like group number 7 elements, definitely they are known for their electronegativity. When it is there, see, we have already started that carbon can share, or yeah, it can share four of its electrons. Now carbon is going to share four of its electrons, so simply it is right there. It is creating two bonds between them. They are creating two bonds between carbon and carbon atoms. One is shared on hydrogen, other is shared with the chlorine. So simply, if we look up to the stress on this group, chlorine is more electronegative. Second electronegative would be hydrogen, and least electronegative or electropositive would be hydrogen. So definitely they are going to attract each other. Chlorine is attracting electrons from carbon, carbon is attracting electrons from the hydrogen. To leave the session. Okay, now the next point would be what we have done so far. We have covered that hydrocarbons is something in which carbon atoms, like carbon and hydro is bonded to hydrogen, and when carbon is going to be attracted towards electrons of another carbon, and the transformation of the sharing of electron takes place between singly bonded structure. This is called as alkane. When electrons were shared between doubly bonded electrons or doubly bonded atoms, that was carbon, that was called as alkene. And when triple bond is present between carbon carbon atom, that was called as alkyne. So that is how the electronegativity is going to make an impact on the bonding, that decides the fate of bonding. So when there is a like from most electronegative to least electronegative, that was shared between, like when two non-metals bonded, we have to consider who is most and who is least electronegative. When it comes to metals and non-metals, that was ionic bonding. So that